Good morning, everybody. Mr. Enyart here with your morning work for Wednesday, week 29. Let's do it. All right, here we go with week 29, Wednesday's morning work. And number one, yeah, that's true. Remember, the median is quartile 2. So over here where we see quartile 2, we could also call that the median. Remember, let's just get rid of this using white. All right, so remember to draw the box plot. You can check the video I made on box plots and IQR, but we're going to look at the maximum and the minimum and make our box plot. Since our max is a nice even 15, I'm just going to go from 0 to 15 on my number line. So your number line should include all of the numbers in your data, and 0 to 15 would do that. So I'm going to do 5, 10 as even as I can here. And then each of those, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Yeah, between 5 and 10 is not that great, but you get the idea. So minimum at 4, you're just going to put a dot right up there. Maximum's at 15, so a dot up there, same horizontal line. Your idea is you're going to be connecting everything straight across, so you want them to try and be in a line. And quartile 1 is a 5, so that's just going to be a vertical line. And then quartile 2 is at 9.5, so that'll be between 9 and 10, right about here. And then quartile 3 at 13, 1, 2, 3. And now you just box them in the quartiles and draw a line from dot to there. And you could label everything. You could even find your IQR, which is quartile 3 minus quartile 1. And 13 minus 5 is going to be 8. So this one kind of seems like a mental math question to me. I mean, if you make 3.5 pounds, right, that's, you can do, in my mind, I'm seeing this as 7 halves, right? And so down here, you only have 3 halves. Well, you can only put 2 3s into 7, and then you'll have one of those left over. So you're going to end up filling, right, because it says she wants to fill it. She's only going to fill 2 bags, right? So if you wrote 2 here, that would work because that's all she can fill. And then she'll have some of another. If you said 3, you need to understand that the third bag will not be filled, but it will have stuff in it. It will have, half a pound in it, but she wants 1.5 pounds in each bag to fill it. So I'm going to say she fills 2 and has half a pound left. What do you think? I have no idea where to go on this one. So again, I'm right to think that this is the number line. And if we were to get rid of it, you know what? Hey, I'm assuming you probably, if you're checking this, you're checking your work and you'll go back and look at your work. So I'll give you a number line to try out. So you do it, you find the IQR based off my number line that I will draw right here. And I'm going to say my number line is going to go from 0 to 10. And that means that this right here is 5, 6, 7, 8, 9, 1, 2, 3. Oh no, that's terrible. 1, 2, 3, 4. Okay, there's my number line. You figure out the IQR. Pause the video. Do it. Okay, IQR is Q3 minus Q1. Q3 is this line right there. That was ugly there. Okay, and that's at 5. And then Q1 would be this one, and it looks like that's at 2. So the IQR would be 3. Here we go. All right, so this is a dot plot, not a box plot that we've been doing, but we're still looking for the median, which still means middle. So I'm going to do these 3 are gone, and these 3 are gone. This one's gone, this one's gone. Let's go 2 and 2, and then we'll do 2 and 2, and somewhere in this mix we're going to be at 11, so our median's 11. So remember with trapezoids, you want to cut them into easier to find area figures. So I'm just going to draw a dotted line here that will theoretically be 90 degrees or a right angle from the base, which is actually at the top here. So we have a square or a rectangle. The 1 centimeter must represent this side. This isn't to scale. And this must be 2 centimeters. Since this is 3 centimeters, that makes this 1 centimeter here. So now I have all the numbers I need. 2 times 1 is going to be 2 centimeters squared for the little rectangle. And then 2 times 1 divided by 2 for the triangle is going to be 1 centimeters squared. And now we just add those two together, the rectangle and the triangle, and we end up with 3 centimeters squared as our area. Again, we're going to trust the numbers, not what it looks like. So I'm going to draw my little break here. And since this is 2 inches, that means the bottom of the square of the rectangle right there has to also be 2 inches, which means since it's 4 total, this little guy here is also 2 inches. I know it doesn't look like it, but according to the numbers, it is. So we have a 2-inch base by 3-inch height triangle, and we have a 2-inch by 3-inch rectangle. That's what we're going to find, okay? So 2 times 3 is 6 inches squared for the rectangle because it's just length times width. And then 2 times 3 is 6 divided by 2 because base times height divided by 2 is how we find the area of a triangle. And 6 plus 3 is 9 inches squared for our area of that trapezoid. Okay, so I think lesson 7 from module 5, a video I just published, grade 6, module 5, lesson 7, focuses on this, but I also have 2 other videos on finding distance between ordered pairs on a coordinate plane as well. Bottom line is, all we're doing is we are looking at what is not the same, the coordinate that is not the same. So either the x's aren't the same or the y's aren't the same. Here you can see 5 and 5 as y. Those are the same. We're going to ignore those. That means they're both 5 units up. So you can imagine here and here, right? I got 2 points. And I'm going to go 5 units up and 5 units up. So they're going to make a horizontal line. So when the y's are the same, you have a horizontal line. And that horizontal line is going to have 1 dot at -3 and 1 dot at +2. So how do you get that distance? Well, if you're at -3, you're going to have to go 1, 2, 3, back to 0, then 2 more. So your distance is going to be 5 units. And remember, since 1 is negative and 1 is positive, that means we are crossing the 0 y-axis. So we're going to add the absolute values. We're always going to use absolute value because distance is always positive. And you'll see that the absolute value of 2 is 2. The absolute value of -3 is 3. Right? Absolute value just turns everything positive. Doesn't make it opposite, it makes it positive. Remember that. It is 5. And so that's how another way we can prove our calculation for the distance. And of course you could draw a number line, you could go make your own coordinate grid and do it, but we're going to go with that. All right, so area of a rectangle is just length times width. So we just have 5.5 times 2.4, which remember you can think of as 55 times 24, and in the end we'll have 2 decimal places. So 4 times 5 is 20, and then we have 22 with the 2 carried. We drop a 0. 2 times 5 is 10. 2 times 5 is 10, plus 1 is 11. So now we add our 2 products. And we're going to put 2 decimal places because there's 2 in the problem there. And it's 13.2 meters squared. Notice I took out that little 0 here because we don't need it. And for a normal distribution, you would just have a regular looking hill that peaks and then comes back down and is centered or balanced or has a line of symmetry, if you will. All right, there it is.